Continuing on with Chapter 11, Problem 39, looking at parts D through F. Again, our strategy is going to be to classify the starting material. Again, in this case, we have a primary alcohol. We're treating that with this reagent, phosphorus tribromide. So what we need to recognize is that this reagent is going to transform an alcohol into a bromide. So we're doing a simple SN2 substitution of the alcohol for the bromide. So keep in mind that for every 1 mole of this reagent, we act with 3 moles of this reagent because there are 3 bromine atoms. So to explain how this happens, we know that the hydroxyl group is a poor leaving group. Therefore, this reagent activates that alcohol. So this happens 3 times. And what we're left with is 3 equivalents of HBr. So essentially what happens, the alcohol oxygen will be protonated. That displaces the bromide anion, which will then act as the nucleophile. So overall, mechanistically, this is an SN2 displacement of an alcohol for a bromide. In part E, here we're taking a secondary alcohol. We're treating that with para-toluenesulfonyl chloride in the presence of pyridine. Then in a second step, we're treating with sodium ethane thiolate. So there are a few things we have to consider in this problem. We have a secondary alcohol, and if you note, I'll draw in the implicit hydrogen atom. So this carbon bearing the alcohol has 4 different substituents. We have a hydroxyl group, a hydrogen, a methyl group, and this rest of the molecule. Therefore, that carbon has stereochemistry. If we recall how to assign R and S to that carbon, the lowest priority group gets a 4. In that case, it's going to be hydrogen. The highest priority group, based on atomic mass, is going to be oxygen. That's 1. Then we're left with carbon and carbon. To differentiate the two, we're going to look what is bonded to those carbons. So here we have hydrogens. Here we have a carbon and a carbon. So this will be 2. That will be 3. So overall, we're going 1, 2, 3. That's a clockwise fashion with a lower priority substituent in the back. So that's going to be assigned R. This first step is actually going to activate the hydroxyl group. So para-toluenesulfonyl chloride has the following structure. It's a benzene ring. And in a 1,4 relationship is a sulfonyl group. There's our sulfonyl functionality, and it's a chloride. Remember that pyridine is the aromatic base. What will happen, the oxygen will attack the sulfur. The pyridine will abstract the hydrogen, and we're left with the pyridinium hydrochloride. So the product of the first step is the following. We've simply substituted this hydrogen for the tosyl group. Now the alcohol is a good leaving group. So in the second step, we're treating with this nucleophile, sodium ethane thiolate. So the sulfur has 3 lone pair of electrons, a formal negative charge, and it's balanced by the sodium cation. So this is going to act as a nucleophile and displace the tosylate in an SN2 reaction. So remember that we assigned stereochemistry to this secondary alcohol. We know that SN2 chemistry occurs with inversion of configuration. So the product from the second step is this here, which is a thiol ether. It looks just like an ether with oxygen, except it's a sulfur atom. So if we assign stereochemistry to this, we'll draw in our hydrogen. The hydrogen gets 4, the sulfur gets 1. Again, we have carbon and carbon. Nothing changes in terms of the priority. That's still 2, that's 3. We're going in the clockwise fashion again, except the lowest priority hydrogen is projected out towards us. So instead of R, we now assign this S. Finally, in part F, we classify our starting material. We have a primary alcohol. We're treating with sulfuric acid. That's a strong acid in the presence of sodium iodide. A strong acid will always protonate an alcohol. So our first step in a mechanism is going to be protonation of the alcohol. We know that hydroxide is a poor leaving group. The acid protonates the hydroxide. You get this protonated oxonium ion. That is now activated for attack by a nucleophile in an SN2 fashion. The iodide will attack the carbon and displace water as the leaving group. So our product is a primary alkyl iodide, and our byproduct is water.